This is another video for CS 3120, and it's about SQL and null values. This is one of the more advanced topics in SQL that we're doing, and it touches on some other computational ideas about what happens when we don't know what something is. There are known knowns and there are unknown unknowns and all of that kind of thing. Anyway, that's enough of a preamble. So the overview of this, I've got what's the problem with nulls, then I've got a little bit of an aside on three-valued logic, and I've got some stuff on using nulls and kinds of workarounds you could use within SQL if you wanted to implement a situation where the world which you are beginning to model in your database contains unknowns and you want to manage those in a way that doesn't cause future problems for your programs and the databases upon which they depend. So, the basic idea about nulls, and this is a quick screen grab from my favourite database textbook, the Manga Guide to Databases, which is databases taught through the mediums of a kingdom which exports fruit and has a database fairy that explains how databases work. Anyway, what the database fairy is explaining in this particular photograph of a textbook is that certain things in a database can't be null. That is, we can't let them be empty, but other aspects of a database might be null. So the database fairy says things like a product code, that shouldn't be empty, product name shouldn't be empty, unit price probably shouldn't be empty, remarks, you might have a remark about a product, you might not have a remark about a product. The database fairy says this kinds of things you might be able to null. Is she right? Well, let's find out. When we think about what we mean by a null, that is an empty cell, what we're talking about is missing information. We know there's a value, or we just don't know what it is at the moment. That's one kind of missing information. So everyone's got a date of birth, everyone's got a birthday. Sometimes you don't know what it is. I've got a friend called Kevin. Nobody knows when his birthday is. Well, probably some people do, but generally people don't know when his birthday is. It's just one of the things about Kevin. But it doesn't change the fact that there is a fact. He did have a birthday at some point. Sometimes, though, the value of an attribute will make no sense at all. So I work in the university. I've got a line manager. It's called Thomas. Thomas has got a line manager. It's called Ian. Ian's got a line manager. It's called John. John's the vice chancellor. John doesn't have a line manager. He's at the top. That's where the boss is. So the vice chancellor doesn't have a line manager. So if you've got a database where every employee has got a line manager, it might not be the case for the CEO of the company or the vice chancellor of the university. So either there's information, we just don't know what it is, or it's not appropriate to have a particular piece of information in a particular situation because it's not actually making sense. So we've got this problem. We need to represent this somehow. There are two ways we can represent missing information. Firstly, you could say we could use a null, which is a database marker that says this is not there. All it means is not there, really. And all it shows is that there is missing information here. So it doesn't indicate anything else. It doesn't indicate whether it's the type of information that used to be, that does exist, or the type of information that couldn't exist. Another option is to have what we call a default value, and you use the default value to represent a missing value. And that might be a date in the past, or asterisks, or question marks. And this means that you've got a default value which says we don't know what this is, and then you change that when you do know what something is. This is a problem because as soon as you've got a value, it's got meaning, right? And that can be interpreted. So the semantics of what you use as a missing value itself has some kind of interpretation. So we have to be careful about that when we're using that kind of object, that kind of representation. The other thing about default values, if you've got a default value, you need to explicitly check it. So, as I've mentioned a few times, code is expensive, code has bugs. If you could get the relational database management system to do the work, you should get the relational database management system to do the work, because tables and joins in a database are cheap, but writing code is expensive, generally speaking. Databases are a very efficient way of getting things done. So what is a null? Why am I spending an entire lecture talking about nulls? Well, it's not a value, it's the explicit absence of a value. What it means is this is not a value, in a sense. There is no value here. There are several real-world interpretations of nulls, and I've hinted at those already. COD proposed a mark for applicable. That is something which is applicable but not known. So your date of birth, you might not know your date of birth, or you might not know your age, but there is a fact of the matter. And then you have I mark, which is for something that's inapplicable. That means, for example, a landline number. You might not have a landline number. You might not have a line manager if you're the boss of the company. It does what nulls don't mean is they don't mean blank. They don't mean zero. What they mean is no value here. We've looked over the last couple of weeks at the concept of relational algebra in the lectures. If you don't know what relational algebra is, then perhaps this isn't the video for you. But if you've got queries, you've got selection operations, you've got things which operate on your data relationally, nulls are going to cause a problem. So if you're doing a selection operation and you're looking whether age is greater than 40, and for some people age is null, do we include those people as being over 40 or under 40? We don't know, right? So you can't know if a null is bigger or smaller than another value, because null doesn't mean a value. If you've got two relations and you want to know if this person named John, address null, is the same as this person named John, address null, do we know if they're the same or not? Well, the information we have about them is the same, but given the fact that this could be anything, we probably can't say whether they're the same. So relational algebra doesn't really handle that situation very well. If you're looking for duplicates, do you count nulls as duplicates? If you've got a null, how do you include them in a sum or an average or a count? And how can you add like 10 and null if you're trying to do arithmetic operations on your data? So SQL generally, the kinds of things that we want to do with data, select, transform, aggregate, maybe averages, maybe sums, don't really work very well in a context where you've got that kind of unknown information. So what we've got is kind of a maybe value. So if you've got nulls, all suppliers in Swansea and all suppliers not in Swansea doesn't actually equal all suppliers if you've got nulls in the location variable. So you've got a kind of maybe. So you've got all of those suppliers where the location is Swansea, all of those suppliers where the location is not Swansea, and then all of those suppliers where the location is null are kind of maybes. We don't know. And that leads me on to the concept of three-valued logic, right? In computing generally, we use two-valued logic. We've got ones and zeros. Computing's all about your ones and zeros. With ones and zeros, we can use truth tables to work out what needs to happen. If we haven't got any nulls and we're comparing A and B, we know that if A is 1 and B is 0, A or B is going to be true if either of them is true. So that's true. That's at 1. For 1 and 0, it's a true for 0 and 1. It's a true for 1 and 1. And it's false if they're both false. That's the definition of OR. With AND, it's only true if they're both true. With equals, it's only true if they're both the same. And this is how computers work under the hood, and this kind of truth table is how we work out how logic works, in a sense. What do we do if we're not sure? What do we do if we've got nulls? What would we say the truth value of A or B is if B is 0 and B is 0 and A is null? Well, we don't know. If B is 0 and A is null, we don't know what it is, so we've got a question mark. If they're both null, again, we don't know, it's a question mark. If one of them is true and the other one is null, well, we know that A or B is true then, because one of them is true. So we can have a 1 in that column. And if the same is true if A is 1 and B is null, we've got a 1 in that column. But if A is 0 and B is null, then we don't know again. And what you're seeing here is the effective truth table for logical operations involving nulls. And what this leads us to is what we call null propagation. That is, all of these question marks are places where we don't know the answer. And when we don't know the answer, it's got to be null, right? What happens if we select in a situation with nulls? So if we select star from employee where salary is greater than 2,000, well, we're going to get greater than equal, we're going to get John and Sarah, we're not going to get Maria. We don't know if we're going to get Harry or not. What should our queries return in that situation? What happens if we use this kind of logic to implement a bonus? So select name salary times 0.5 as bonus from employee. This means that there's going to be something in the bonus column for John, Sarah and Maria, but there's going to be nothing in the bonus column for Harry because Harry's salary is null, and 0.05 times null is not something we can work out, unfortunately. If you're using group by functions or other aggregate functions, you got the same problem. If you've got a null, it's very difficult to work out what should happen next. The results of anything arithmetic involving nulls, also nulls. So 200 nulls is null. Concatenating strings with nulls, also null. So if we concatenate the string cheese and the string null and the string onions, you don't get cheese onions, you just get null. That's just the way it works. And finally, if you're doing joins, when you take the join of two relations, what happens is you match up those tuples which share values, and any tuples which don't have a match are simply lost, and these are sometimes called dangles. If you've got an outer join, if you calculate an outer join, it will include any dangles in the result and use nulls to fill in the blanks. So outer joins will actually introduce nulls into your database. So this is another case of null propagation. So here we've got a student table. This is the enrolment table. This is the student table. And we've got 3 students, Thomas, Mary and Clarice. And then we've got enrolment table with sums, pictures, stories and sums. And they've got student IDs representing which students are on which modules. And what we're doing is we're selecting star from student with a left outer join of enrolment on student ID equals enrolment.id. So we're taking everything from student and we're joining it to enrolment on student.id equals enrolment.id. And that's going to give us everything apart from those where effectively we've got dangles. So you get everything from the left hand table in a left outer join, and everything that matches from the right hand table with NULLs as appropriate. And so if we look back at our previous slide, Keris here, student ID 882, is not in this table. These two modules don't have students registered in this one. So what you end up with is Keris student 882, and then you get NULLs as appropriate. So this is a situation in which your database will develop NULLs even if it didn't have them in the first place. So left joins, right joins, inner joins and outer joins can all introduce NULLs into your data. Arithmetic operations can introduce NULLs into your data, selection operations, and so on. So if there are NULLs, there will be problems with these things propagating in your database. Joins in particular can be problematic. Sometimes those joins are the most practical approach, and we might still want to see what's going on. Effectively, it's a problem. So what do we do? Well, you need to be sure when you're going to allow NULLs, and you need to think it through. So if you're designing a database, you should try and make sure that as many fields as possible aren't null, unless they really could be null and there is a real serious reason for them to stay there. You should allow NULLs when your model has unnamed values, or when only one meaning, for example, like the Vice-Chancellor's boss case, is implied by the term null. And also if you're not using two-valued logic, although that's kind of an advanced technique thing to talk about now. If you're going to be representing several things by the concept null, so if you're using null to do more than one type of work, like missing value, out of range, inapplicable, undetectable, these are all different things you might mean by null. Use a different concept. So you shouldn't have nulls in keys, and you shouldn't have nulls in foreign keys. Well, you can. You could have a null in a foreign key explicitly in cases like the CEO's supervisor or the Vice-Chancellor's boss. So a null in a foreign key is basically saying there's normally a link between this table and that table, but in this particular case that link isn't present. It's better to represent this stuff by introducing a new table, really, rather than having mandatory relationships which have nulls in them, just because nulls are weird. Hopefully I've convinced you of that much so far. You can use something called an indicator attribute, like telephone number, an indicator attribute which would extend a domain to include something which indicates status. So telephone number is the example I'm going to use here. So we're going to have an extra attribute, we're going to call it status. So you've got telephone status is effectively a single value. You always assign values to both, so you don't have any nulls. And if you're doing a query, what you do is you check the status before you use the actual telephone number. And you can have examples. This is an example of how you might do that. So here's a telephone number, and the status is valid. There's an indicator value, which is 0000, and the status is not known. There's a telephone number, indicator valid. There's a telephone number, status is disconnected, X directory, no phone. So there's different things that we could mean, different things that we could know about values. And by having the indicator in the status, what we get is a situation where nothing is ever null, so you're never going to get that null propagation problem. And you're actually storing more information about the world, so you've got more detail about what's going on. So you know whether this indicator value, which could just simply be null, is a case of we don't know, or there's something going on. The only thing that means this is an actual valid value is the status value valid. So that's a kind of quick overview of a tricky topic about how you might store nothing in your database. It's interesting to think I've just basically done a 20-minute video on nothing. There we are. Life is strange sometimes. Anyway, Nulls can be problematic in databases. They don't represent zero, they represent unknown stuff. And you have to think about how they're going to be propagated through your data model, and also about how you're going to deal with them in terms of three-valued logics. Sometimes you can't avoid them, sometimes you can work around them, sometimes you can use indicator values to get around them. I should give a shout out to Edel Sherratt for an earlier lecture on NULLs, which heavily inspired this one, and I'm going to finish up with a single slide overview of what we need to do with NULLs, and that is be careful. Careful now.